Okay. There we go. Yeah, thank you everyone for joining today. Today we have Sneha. She is going to talk about small steps with artificial intelligence, and she will explain the basic difference between AI, data science, machine learning, and deep learning. And she will dive into the history of AI and how we had two cold winters. So Sneha is a third-year graduate pursuing a degree in BTech in the field of computer science with AI. She is passionate about data science and machine learning with special interest towards data analytics, and has practical experience with business analytics using tools such as TableAU and Power BI. And she has worked on other small-scale projects such as a spam filter and sentiment analysis. And she has industrial exposure in the field of technical content writing. And she enjoys the creative process of designing and making posters. And her hobbies include reading books, classical dancing, and acting. And that was really cool. I wish I could dance. But yeah, so that's our introduction to Sneha. I'm going to stop sharing my screen and let her start her talk. So, and if anyone has any questions, please ask them in the Q&A box at the bottom. You can find it in your toolbar. And please ask your questions in there. But that'll be me. I'll stop sharing my video as well, and I'll pass it over to you, Sneha.
Thank you. Thank you so much for that introduction. I'll start sharing my screen. So is my screen visible?
Yes, I can see it.
Okay, cool. Okay, so thank you so much everyone for coming out today. I'm sure you're all from very different time zones and you've all made the time to be here today. So thanks a lot for that. And I'm really excited to take this session. So let's get started. So this is what we're going to talk about today. So first, we'll talk about difference between AI and traditional programming. And then we'll talk a little bit about the origins and the history of AI. Then we'll talk about the buzzwords that revolve around AI, especially data science, machine learning, and deep learning. And we'll also learn how they're interrelated with each other. Then we'll also talk about some interesting applications that revolve around AI. So now let's get started with AI versus traditional programming. So before we get started, I'd like Sapphire to put the first poll question where it asks people what your first ever impression of AI is. Sapphire?
Can everyone see the poll? Can you see it, Sneha?
Yeah, I can see it.
Perfect.
So let us know on the chat once you're done filling the poll. Great.
We're just waiting on a few more people.
Yeah, sure.
Yep, that's us. So I'll end the poll now and launch the results.
Okay, wonderful. So we will discuss these results a little later when I'm actually talking about AI, but it's really nice to see what opinions you all had about AI. Very nice to know. Okay, so let's get started. We'll first talk about AI versus traditional programming and how these are different. So in traditional programming, it's essentially a very manual process. So a programmer who's programming using traditional programming, what happens here is that for the particular program, this programmer gives out all the rules, the entire logic for the program, the rules that revolve around how the program should function, everything is clearly typed out by the programmer. So this is almost, you can think of it like the programmer is giving the program a rule book and telling the program, okay, so you should follow this rule book and act according to it and give us the output. So as you can see in this diagram here, the programmer gives both the program and the input, and that combines together to give you the output. So that is traditional programming, where you're giving all the rules on your own as a programmer. Now, artificial intelligence is more of an automated process. So what we have in artificial intelligence is an algorithm. And for this algorithm, you don't have to explicitly give all the rules and all the logic. No, it will learn on its own from the data and it will formulate its own rules. So as a programmer, you just have to give in the input and the output that you expect from that particular model. And then that program will learn the rules on its own from the data that you've presented to it. So that is the basic difference between traditional programming and AI. Here it's more of a manual process, and there it's more of an automated process. So to help you understand better, let me explain this with a tic-tac-toe example. So suppose you are asked to program tic-tac-toe, and first you choose to do it in the traditional programming sense. So what would you do in that case? You will have to program each and every single thing. So you will tell the program, okay, so for tic-tac-toe, there will be a 3x3 grid. You can have only 2 symbols, that is X or O, and you can only fill 1 symbol in one particular grid. And to win this game, you must have either like a series of X's or rows, either horizontally, vertically, or diagonally. So each and every single rule that's associated with this game, you're telling the program. But when it comes to artificial intelligence, suppose you're giving artificial intelligence, that's how you're programming this. Then what you will do is, to that machine, you will show examples of tic-tac-toe games, either games where X1 or O1 or where both is draw. You will show these examples to the machine. And then from that, so that is the data that you show in the machine. So from that data, the machine will learn on its own. It will understand the features on its own from that game. So from there, it will understand, okay, so tic-tac-toe has 3x3 grids, and you need to be either an X or an O, and you need to win in this manner. So that all those rules will be formulated by the machine based on the data that you give it. So I hope that was clear. And at any point, you can always ask your questions and questions in the question answer forum. And definitely there'll be Unison Sapphire who are looking into it. So they'll also answer your questions along the way. So please don't hesitate and ask anything. If it's a small doubt or a big doubt, anything, please ask. All right. So now we'll move on to the history of AI. So I believe that for you to completely understand any technology, you need to know its origins. So we'll start learning about the origins of AI. So it all started when Alan Turing, he published a paper known as Computing Machinery and Intelligence, where he proposed something known as an imitation game. So there he just asked one very simple question. Can machines think? So for understanding and analyzing if machines can think, he proposed something known as a Turing test. Now, what is this Turing test? So Turing test is basically when you have a human judge, and the human judge has to chat with a set of people on the other side. Now, these necessarily don't have to be people. They could be robots or people. They could be bots or people. Now, if the human judge cannot distinguish between the human and the robot, then that robot is said to be intelligent. So if the robot can actually converse in a manner that confuses the human judge to think that that person is actually talking to a human, then you consider that bot to be intelligent. So that was the Turing test that was proposed by Alan Turing, and that happened in 1950. Then we move on to 1955 with the checkers game. So that is when Arthur Samuel wrote a program that let a machine learn to play checkers all on its own. And the really beautiful and fun fact here is that Arthur Samuel himself did not know how to play checkers, yet he programmed a machine that learned how to play checkers on its own. So that's really fascinating. Then we move on to 1956. 1956 was a very pinnacle moment in the field of AI, because this was the time when the Summer Dartmouth Conference was convened, and that was when John McCarthy, who is considered the father of artificial intelligence, actually coined the term artificial intelligence for the very first time. So that happened in 1956. Then between 1956 and 1974, there were some other developments in AI. For example, we had the first ever chatbot known as Eliza. Now, Eliza was the first ever machine to actually beat the Turing test. So Eliza was this chatbot who made the human judge believe that she was actually a therapist. So then the human judge got confused and labeled her as a bot, as a human. So that's how she passed the Turing test. And apart from Eliza, there was certain other developments also in the field of AI. For example, Japan came up with its first ever humanoid robot known as Wabot 1. But what happened is that most AI researchers, they jumped the gun. They thought they could deliver more than they actually could. And lots of areas of research that they delved into failed. So what happened is that the government stopped funding a lot of AI researchers. And since the funding was low, the research about AI was low. So that's why the period of 1974 to 1980, since there was very low development in AI, very less research or very less funding also given to AI researchers, this period is known as AI winter. And this was the first ever AI winter we had. So this is John McCarthy. And this is actually a quote he told in that very own Dartmouth Summer Conference, where he said that this research will proceed on the basis that every aspect of learning or feature of intelligence can, in principle, be described so accurately that you can create a machine that simulates them. So this is what John McCarthy said in that particular conference. Moving on. So we had the first ever cold winter till 1980. Then 1980 came up the expert systems. Now, what are these expert systems? They help in mimicking the decision-making ability of a human. So these are systems that help you answer yes or no questions. So apart from these expert systems, there were also certain other developments, like Japan again came with an improved version of the humanoid robot known as Bobot 2 this time. And there were certain other developments as well. But just as the first AI winter, the same trend followed here. People again jumped the gun. People thought they could deliver more than actually what they could. And again, the funding towards AI was low. There were research that didn't go well, that didn't give you the necessary output. So again, there was another winter. This was the second AI winter, and this was from 1987 to 1993. Then in 1997, shot up Deep Blue. What is Deep Blue? Deep Blue was the first ever chess playing computer that actually beat a world chess renowned champion known as Garry Kasparov. So that was a real boost to the field of AI, to actually have an AI that beat a human at something. Then from 1997 till 2011, we had some major developments in the field of AI. We came up with our first ever robot vacuum. And in 2006, companies such as Facebook, Twitter, and Netflix, they took AI and brought it to their business. And there were many other such developments. Then from 2011 to now, there had been a boost in deep learning and DNNs. So I will speak a little bit more about what deep learning and what a deep neural network is when I actually reach there. But just know that from 2011, there's been a huge boost in this field. And we also found out another chatbot that beat Turing test, which is known like the chatbot's name is Eugene Roostman. So this Eugene actually convinced the human judge that it was a 13-year-old Ukrainian boy. So that chatbot basically used to speak in incorrect grammar and always used to derail sentences, change topic frequently. So then the human judges believed that, okay, this is probably a very distracted 13-year-old Ukrainian boy, but it's actually a chatbot. So that was the timeline of how AI developed. And now AI, as we see it, we can see it all around us. We use it almost every day in our lives. For example, tagging Facebook photos, and we have spam filters, and even our voice assistants such as Siri and Alexa. All right, so any questions anyone has so far, please put it up in the Q&A forum. And if you have any other suggestions, or since I only gave, spoke about certain pinnacle moments in the development of AI, if you have any other, pinnacle moments or moments that you think was amazing that you need to share with everyone, please do so in the chat box. Okay, so Nada has asked a question. She asked, "Are AI memorize all the movements in all spots on tic-tac-toe?" Nada, no. So what actually happens here is that when you give, what you're doing is you're giving AI examples of games of tic-tac-toe. So when you give these example games, it learns how to play, and it does not play with itself. It plays with another opponent. So it's not like it plays with itself. It just, by that example, I meant to let you know that AI learns the rules of its games on its own based on the examples that's given to it. I hope I answered you, Nada. You can perhaps put a thumbs up in the chat if that's okay. Cool. Any other questions or anything any of you would like to share about what in AI interests you, or what do you know, anything at all? All right. Oh, okay, there's another question. Okay, what do you think of the chances of, so Sunil asks, what do you think are the chances of having a third AI winter? So most scientists predict that this third AI winter is actually quite impossible, because back in when the 1980s and the 1970s, when we did actually have AI winters, that time AI was not our main field of usage. We didn't use AI in a lot of applications. So when people said, okay, this system is powered by AI, then it would be a very surprising thing, because, oh, wow, AI, okay, we must go there. That's how it used to be. But right now, most of our daily life also depends upon AI. So and research is growing very, very fast in the field of AI. So most scientists predict that there will not be a third AI. Sunil, I hope I answered your question. You can put a thumbs up or something in the chat. Cool. Okay, I will be moving on. So now we'll talk about the buzzwords that surround AI, such as machine learning, deep learning, and data science. So, so this is the basic diagram of all the buzzwords that surround AI. So as we can see here, AI is like this huge umbrella. Under that, we have a subset, which is known as machine learning. Under that, we have another subset known as deep learning. And then we see that data science, although it does use AI, machine learning, and deep learning, it also has certain facets that make it a little separate from these three fields. So what is artificial intelligence exactly? These are machines with the ability to reason like humans. And a subset of that is machine learning. Now, what are machine learning? Machine learning is systems or algorithms that learn without explicitly being programmed. So when we spoke about the difference between traditional programming and AI, we saw that this is AI is an automated one that learns without explicitly being programmed. So it's machine learning that actually helps AI with these algorithms that learn without explicitly being programmed, without explicitly actually telling all the rules to it. Now, deep learning is a subset of machine learning. And this also, just like machine learning, deals with algorithms that learn without explicitly being programmed. However, this is mostly used when you have vast amounts of data. So that's when you mostly use deep learning. Now, data science. While data science does use machine learning, artificial intelligence, and deep learning for solving some problems, it also requires a specific set of skills and a specific set of knowledge, such as mathematics, statistics, and domain knowledge. So domain knowledge deals with the field in which you're working in. I'll explain a little more about that with an example when I actually reach data science. But yeah, so this is the basic difference. We have AI, under that we have machine learning, deep learning, and data science is a field that combines a little bit of this, but also has certain characteristics of its own. So now let's start with artificial intelligence. What is artificial intelligence? These are autonomous machines. So these are machines that can perform any task with not much human intervention. It requires very little human intervention by performing a task. And now, what are these tasks that AI performs? AI performs human-like tasks. So take, for example, a robo-vacuum. You have a robo-vacuum. So this robo-vacuum would, navigate around the house to actually clean the house, right? And it navigates on its own. So it does not require a lot of human intervention. And what is the human-like task it does? It performs a human-like task of cleaning. So that is a very basic example of AI. Now, what AI does is that it helps us manage, model, and analyze very complex systems. So what does this mean? Let's again go back to our example of the robo-vacuum. Now, in this robo-vacuum, for the robo-vacuum to actually navigate, it needs to know the environment around it. It also needs to make sure that it does not hit any chair or table or anything in its path. It needs to move about in a clear path, but also clean the entire house. So for all this, you need something to help it navigate, some systems for object detection. So there are many systems that in turn help it finishing its goal, which is cleaning the house. So that's the robo-vacuum, and this is what artificial intelligence is. So artificial intelligence is broadly divided into three categories. So we have artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. So now let's first talk about artificial narrow intelligence. What exactly is that? It's also known as weak artificial intelligence. You might ask why. It's known as weak artificial intelligence because it can only perform one single goal that's given to it. Although it performs that particular goal very efficiently, that's the only goal that it can perform. So all the practical implementations of AI we have right now in the world, they are all artificial narrow intelligence. All systems are programmed to perform only one task. There may be other things that are helping it to perform that one task. For example, as we saw in the robo-vacuum, we have something to perceive the environment, something for object detection. All of that in turn help it to perform just that one task, which is cleaning. You cannot expect a robo-vacuum to perhaps go and open your door for you. No, robo-vacuum can only help in cleaning your house. So that's the practical implementation of AI we have now. AI that performs just one task. Next, we have artificial general intelligence. Now, this is also known as strong AI. So such AI, they don't just perform one task, they perform a lot of tasks. And while in narrow intelligence, that we give input to that particular intelligence and artificial intelligence machine, and it performs the task on its own. But here, it does not just, in general intelligence, it does not just work based on our input. It also takes the input of the environment around it on its own. It is self-aware, and it's, it can It has emotions and it works on those emotions. It performs results and it performs many activities based upon the emotions that it actually feels. So such machines are programmed in a way to act indistinguishable from humans. They almost resemble humans because they are self-aware. They know their environment around us and they have emotions and they're driven by that also. So that is artificial general intelligence. So while we don't have an implication of this right now, in practical sense, it's been portrayed in many movies and many TV shows. I'm sure many of you would have also seen many of these. Then we have artificial superintelligence. Now, this is a totally hypothetical scenario, and that is why it's known as hypothetical AI. So what this is that these are machines that are capable of expressing intelligence that surpasses even the brightest human experts in any given field. So that means super intelligence is something that is going to be the smartest among all human beings. The human beings will be the dumber ones in comparison to this particular super intelligence. So this is completely hypothetical, and this even general intelligence has not been implemented. So this is far from being implemented. So that's about the three broad classifications. Now let's go back to the poll that you guys answered in the beginning. So I guess most of you said that AI is mostly a robot. And then some of you also said that it's a super intelligence that can take over the world. So, okay, so let me first address the robot answer. So when you say AI is mostly a robot, it doesn't necessarily have to be a robot. It can also sometimes just be a software. Like you can take Siri, for example. Siri operates on your mobile. Your mobile is not a robot, but that is also an artificial intelligence because it works on its own. It takes your queries and gives you replies. So that is also an AI, but it's not exactly with a robot. But yes, robot is partially the answer. That's good. And for those who said it's a superpower that's going to take over the world, that is totally hypothetical. I hope you understood that from this example, that what we have right now in the physical implementation that we have right now is artificial narrow intelligence only. So super intelligence is something that's part of movies. So maybe I can stop here and ask you, let me know what your favorite movies about AI are. Like there are so many movies that deal with robots and robots that can take over the world and things like that. So, and if you have any favorite movies, please let me know in the chat box. iRobot, nice. Anyone else? Oh, wow, that's nice. I selected Robot because as a kid, I was fascinated with the movie Tobot the Great, iRobot, Avengers Age of Ultron. Wow. The TV series Humans. Oh, wow, that's amazing. Really nice to know. Okay, so let's continue. So that was all about AI. And let me continue on with some examples. Okay, so here what we see on the left is Sophia the robot. Now, Sophia the robot was a robot who was built by Hanson Robotics in Hong Kong. So what makes her so special? She's a very advanced robot who's mostly like a conversational expert, and she was built to form relationships with humans. So how she works is that it's literally like talking to a human when you talk to her, because she can make facial expressions. So suppose she says a joke and then you're laughing, she will also laugh. Or suppose you make a comment and she thinks it's not nice, she'll make a frowny face. And she's also a conversational expert. So she'll know replies to your query. She knows witty replies and this and that. And she really helps in forming relationships with humans. So very fun fact about Sophia is that she's the only robot to have citizenship. So Sophia is a citizen of Saudi Arabia. So that's about Sophia. Then over here on the right, we have Deep Blue. So if you remember from when I spoke about the history of AI, Deep Blue was the first ever chess playing computer developed by IBM that actually beat world-renowned chess player Garry Kasparov. So this is how Deep Blue looks like. So these are some examples of AI. And next we move on to machine learning. So right now we spoke about AI. These are machines that have the ability to think like a human. So a subset of that is machine learning. Machine learning are rather the algorithms that learn based on data. For these algorithms to work, you don't have to program every single rule. They learn based on the data that's given to them. So this is the process of using statistical learning algorithms to build machines that learn on their own, and they don't have to be manually programmed. So Zendesk is a great website for you to learn about articles about AI and machine learning. Zendesk describes machine learning, as algorithms that pass data, passes as in converted to machine readable form, learn from that data and then apply what they've learned to make informed decisions. So that is what machine learning is. These are algorithms that learn from the given data and apply what they've learned. So machine learning is also classified into 3 categories. We have supervised learning, unsupervised learning, and reinforcement learning. So supervised learning models, let's talk about those. So for these type of machine learning models, the input we give are labeled. So we know the kind of input that we're giving it to because we label it. We know that this particular input we're giving to this. So we know the kind of output that we expect from such systems. So these machines learn from the examples that we give to it and then predict the output. So let's understand it better with this real life example. Let's call it boy and colors. So imagine you're trying to teach a toddler to identify the color red. So first you give a red color cardboard box and you say, okay, this is the color red. Then you give a red color pencil and you say, this is also the color red. So now you've trained the boy. You know that, okay, so the boy has learned from these examples. It knows now by looking at the color that if it's a color red or not. So then you give the boy an apple and you ask the boy, okay, what color is this? The boy will reply with red because you already taught the boy from the cardboard and the pencil that it was red color. So the boy now knows that it's red in color. This is exactly how a supervised machine learning model works. Assume the boy to be a machine learning model and this red color cardboard and red color pencil to be your labeled inputs. So you're feeding the model the color red. And then when you feed it new data and ask it to predict if it's a color red or not, it knows, it's been trained already from these examples that you gave it, what the color red looks like. So then it will predict whether this is the color red or not. So that is about supervised machine learning models. Next, let's move on to unsupervised machine learning models. So in supervised machine learning models, we given labeled inputs. We knew what the input was. But in unsupervised machine learning model, we don't given labeled inputs. We given unlabeled inputs. We don't know what these inputs are about. And we give this to the model. So what? The model has to do everything right now because the model has to learn features of commonality between the examples that we're giving it and cluster it in those groups according to similar features. So that's what unsupervised learning is about. Let's again look at it with this example. So let's have this example known as ice cream flavor. So suppose someone has assigned you a group of people and now they want you to group these people according to some hobby, something they have in common. You also don't know anything about these people and the person who assigned you the people also doesn't know anything about these people. So then you're at a loss. So you're asking people, okay, what are your likes, what are your dislikes, what are your hobbies, what are your interests? You keep asking them. And then you finally find out that some group of people have one feature in common and that is their ice cream flavor. So you group them according to that. So perhaps these people have mango as their favorite flavor, these people have chocolate and these people have pista. So now you found that one link, that one feature of commonality among these people and you group them accordingly. This is exactly what unsupervised learning model does. It takes in data that you have not labeled. So you also don't know what the output is. And then from that data, it learns, it understands what the features of commonalities are among data points in that particular data. And then it clusters them or groups them into separate clusters. So that is about unsupervised learning. So in unsupervised learning, we're giving in unlabeled examples. We also don't know what these examples mean. And then the machine learns on its own how to classify them. Next, we have reinforcement learning. So while supervised and unsupervised had pretty clear distinction, here you gave labeled examples and here you are giving unlabeled examples, reinforcement learning does not have such a clear-cut distinction when compared to these two. So you can think of reinforcement learning as a model that learns from its mistakes. So consider it to be like an AI agent just left in an environment and it does whatever it wants. But for every action that it performs, it gets either a positive feedback or a negative feedback. So let's maybe try to understand this with the tic-tac-toe example I've spoken about previously. So that's here. So I said, when I initially spoke about this tic-tac-toe example, I said that we would give the machine different games of tic-tac-toe. We would give the machine perhaps games in which X1, O1 or ties, and then we make the machine learn the features. So that is an example of supervised learning because we're already giving it labeled examples and we're training the machine based on these labeled examples. Suppose this was reinforcement learning. Then we would just leave an AI agent in an environment where it knows that the two symbols are just X or O. So that's it. It's just left around in this 3x3 grid. That is the AI environment for it. And it knows that two symbols are X and O. So it won't even know how to start. Perhaps, see, in tic-tac-toe, you have to only put one symbol in one particular grid, right? So maybe when the reinforcement learning starts playing for the first time, it puts all the symbols in one particular grid. So that's the wrong way of playing. So then we would give it negative points based on that. So this is how reinforcement learning is training. It's based on positive and negative feedback, where you just leave an AI agent somewhere and then it learns from experience. So let's talk about a real life example to understand this a little bit better. Let's call this dog and treats. So suppose you're training your dog to actually get the newspaper for you every morning. Whenever the dog does this particular thing successfully, you're giving it treats. And if it doesn't do it successfully, you're not giving it treats. So you're training the dog to do that particular activity with positive feedback, which is treats in this case, or negative feedback, which is not treats in this case. So that's all about supervised learning, unsupervised learning, and reinforcement learning. Just to recap, supervised learning, we give in labeled input, and the machine learns from this labeled input. Unsupervised learning, we give unlabeled input, and the machine has to form the features all on its own. And in reinforcement learning, we just leave an agent in an environment, and the agent has to move around and perhaps do some action and understand how it should operate based on the positive and negative feedback you give the agent. All right. So now let's talk about some examples of machine learning. So here we have Netflix, which is known as a recommendation engine. Now, what is this recommendation engine? Whenever you watch perhaps a movie or a show on Netflix, then based upon whatever you watch, there will be so many other recommendations. Like, for example, you watched a K-drama. It will say, since you watched this K-drama, we're also recommending so many other K-dramas. So you know that Netflix is not the only recommendation engine. We have YouTube, which also recommends videos based on what you've seen. We have even e-commerce sites like Amazon. If you buy a certain product, it will say people who bought this product also bought so many other products. So that is an example of recommendation engine. Then we have spam classification. So in spam classification, like you have in Gmail, you have a particular label known as spam. So if a certain mail has certain ambiguous words, weird words, or things like that, then that gets classified into a spam folder. So these are examples, like perhaps it says send in your bank account details because you have won a great prize. Then Gmail will know that that particular message is spam, so it will take it to the spam folder. So these are the examples of machine learning. Now I'd like to ask Sapphire to release the second poll, where I want you guys to classify under which category do these examples fall under. What is the recommendation engine? Is it a supervised machine learning model, unsupervised, or reinforcement? And what is spam classification? So let me know in the chat box once you've. So Sapphire, has everyone answered the poll?
Just waiting on a few more people.
Okay.
Yep, that's us now. There we go.
Yeah, done. Okay, so the answer actually is unsupervised learning and supervised learning. So let me explain how. So 1 second. Yeah, okay. So Netflix is called unsupervised learning. Why is it called unsupervised learning? It's because so the users that come to Netflix, consider back the ice cream example. So the users you don't know anything about users. Netflix does not know anything about these users that come to use this particular site. But these users are grouped based on their common features. Now, what is their common feature here? That particular movie you saw, or that particular TV show you saw. That is the commonality that Netflix finds. So it puts you in those groups. Now, Netflix additionally recommends you movies or TV shows based on the group that you fall under. So that is why it's unsupervised, because there is no labeled input that's being given. It's unlabeled. The group of people are unknown. That is why it's known as unsupervised. I hope that's clear. Now, spam classification is not supervised, because while you're training the model, you're initially giving it some examples. So there will be examples such as there will be ambiguous mails, perhaps you put it in your spam folder. So then through that, it will learn that, okay, so these, weird sounding mails, or these mails that really don't have a proper purpose, or these mails that are really very terrible grammar, these are all spam mails. So that it learns from input labeled examples. So that is why it's known as spam classification. So it's known as supervised learning. So I hope that's clear. All right, next we'll be moving on to deep learning. So far we spoke about artificial intelligence and machine learning. So artificial intelligence is, these are machines that are autonomous, that can think on their own, that have the ability to think like humans. While next we have machine learning, which are algorithms that can learn from data, learn without explicitly being programmed. You don't have to program everything there. They can learn on their own. Next we have deep learning. So this is a subset of machine learning. That is, it tries to mimic the way that the human brain actually filters information. And like I mentioned before, deep learning is mostly used when you have large amounts of data. So when using this large amounts of data, it's a subset of machine learning that helps to mimic the way the human brain actually filters information. So you know that in our human brain, we have a network, a neural network. We have a neural network in our human brain, and that's how information is filtered. That's how we understand things based on this neural network. So this is what we're trying to simulate artificially in a deep learning network. So to accomplish this filtering process, what we have is several layers of processing units. So this one single processing unit is known as an artificial neuron. Okay, and you cannot really accomplish, if you have just one neuron in your brain, you would not be able to do any of the tasks you're able to do. You need a connection of neurons for you to perform the various tasks that a human body performs. Similarly, for deep learning to perform the various tasks that it does, it needs a connection of neurons. So that neural network that is connected, it's known as an artificial neural network. And sometimes you cannot just stick to one layer of artificial neural networks. You need many, many different layers. So these layers make the artificial neural network deep. That's why when we had spoken about in the history of AI, there was something known as DNNs. It's called deep neural network. So these deep neural networks are what is used to actually process the information in layer by layer. And this helps in processing large amounts of information, not like machine learning cannot really deal with large amounts of information. So let me take an example of image classification. Suppose you have an image and you need to figure out the face. You need to find out where the face is in that particular image. So the face is made up of a lot of features. You have the nose, the cheeks, the ears, the lips, a lot of features. So with machine learning, it will not exactly with that amount of data and so many features that it needs to learn from, machine learning will not really perform efficiently in this area. So for that, you need deep learning. So for that, you need layers, that is deep neural networks. So that means perhaps the first ever layer will try to detect the nose. The second layer will try to detect your cheeks. Like that, many layers combined, you will get your output. So that's about deep neural networks. There are many other different types of neural networks as well, but we'll just talk about deep neural networks here. So now this is a comparison of the biological neuron with an artificial neuron. So in a biological neuron, you have something known as dendrites. So dendrites is from where you actually get your information from other neurons. So we can see here in 1, in 2, so on till in n. So that is the information this particular neuron is getting from the other artificial neurons. Then you have the cell body. Now cell body, so dendrites get these electric impulses, and these electric impulses are information that's in the brain. So the cell body is what processes that information. So that's what processes the information here. And the cell body's role is done over here. So we will not be speaking exactly about bias in this particular session, but just know that bias is something that helps this artificial neural network or artificial neuron to process the information that it gets from the other neurons. Now, in our biological neuron, once the information has been processed here, it goes to the axon and goes to the axon terminals. And from those axon terminals, it's given to other neurons in the neural network. Similar thing happens here. So once it's been processed, we get an output, and that output is sent to various other different neurons. So that is a comparison between like a biological neuron and an artificial neuron. So here we talk about an example of deep neural network. So that is AlphaGo. So AlphaGo is Google's deep learning based program that can play the game of Go. So when AlphaGo was first invented, it was not very good with the game of Go because, again, like we said, we didn't program any rules. It has to learn on its own. So when it's starting out, it was not very good. But after playing with many Go champions, it learned the game of Go and it became so intelligent that it right now has actually beat some world-renowned champions in the game of Go. So that's an example of deep learning, which is AlphaGo. All right. Now we're on to our last buzzword for today. So right until now, we spoke about artificial intelligence, about machine learning, and about deep learning. So artificial intelligence, again, machines that have the ability to think. Machine learning is an algorithm that learns without explicitly being programmed. Deep learning is the same. They are algorithms that learn without explicitly being programmed, but they deal with large amounts of data. So they have different layers and they have processing units known as artificial neurons. So now we have data science. While data science uses the other three facets, it also has certain criteria of its own, such as mathematics knowledge, statistics knowledge, and domain knowledge for it to work. So data science, as the name suggests, focuses on data. So very important step of data science is for you to collect the data, to analyze it, to visualize it, and to get meaningful relationships that are formed from the data. So you don't just immediately predict yes or no, as we do with artificial intelligence, machine learning, and deep learning. You need to know the data that you get. You need to understand the data that you get. And based on that, to solve a particular problem, we perhaps use machine learning or deep learning. So it's a field that combines domain expertise, mathematics, statistics, and programming knowledge to derive meaningful relationships from the data. And we also use visualization, so perhaps bar plots or scatter plots, to uncover hidden patterns that are present in the data. So let me explain this with an example. Suppose you're in a hospital and you need to predict the chances that a particular patient gets breast cancer or not. So for that, you need to first take the data. You need to access many age-old patient records, patients who have actually had breast cancer. And then you will take all these patients' records and you will analyze the field. You will see what are the commonalities between the people who have had breast cancer. And for you to do so, it will not be very easy for you to just look at it one by one, one below the other. You will need to visualize it to actually uncover the relationships that are present between these different types of data that are there. So you will visualize it and you will understand what this data is all about. So that is the step of analyzing the data. You cannot just take the data and immediately predict if a person has breast cancer or not. You need to sit down and analyze the data by taking in different examples and drawing visualizations and things. And then later on, when you have to actually predict if a new patient has breast cancer or not based on your given data, that is when you use machine learning or deep learning, and you use that particular data and give it to a machine learning model, program it based on that, and then predict. So that is an example of deep data science. And I'll pause here again for questions. I hope what I spoke about was a little understandable, and I hope that you all learned something from it. So please let me know what you understood and what it was like. Okay, so
we have some questions. We have some questions in the
yeah, I'm reading those right now. I see we have 3 questions. Okay, so Meredith asks, for Netflix, don't users give it feedback on suggestions that it would use to improve its recommendation? I don't know, but I assumed it was reinforcement learning based on that. Oh yes, so yeah, definitely you give feedback back. You give feedback, but that's not the main thing it works on. So in reinforcement learning, the agent is left all on its own, and it is not given anything in the beginning. But here in Netflix, you have a certain set of users that are given. There is something you give a certain amount of input to Netflix. So that is why first it is categorized as unsupervised learning, because from those users, it takes a common feature. It tries to derive a common feature and then classifies them, and then it goes on to. So in machine learning, they can always make mistakes. So that is just reiterating or learning from mistakes, but it's not exactly reinforcement learning, because you're initially giving it unlabeled input. That is why you first classify it as unsupervised learning. Meredith, I hope I answered your question. You can let me know in the chat. Or if you have a follow-up, you can. Oh, okay, great. Sunil asks, voice assistants like Siri, Alexa can perform a plethora of tasks, such as setting alarms, booking tickets, completing transactions. And he's listed a lot of tasks. With this in mind, would you label voice assistants such as narrow as artificial narrow or artificial general intelligence? If narrow, is it because it's done singular task being referred? Here would be processing voice commands and multiple actions a voice system can perform be considered as multiple outputs and not tasks per se. So I guess, Sunil, what you're trying to ask is, since you ask a voice assistant so many questions about tell me the weather, play my favorite music, and so many other different questions, you're asking me if this is artificial general intelligence. No, because like you said, narrow, a singular task is being performed here. Your voice is taken. It is so I'll explain a little bit more about voice assistants like in the next slide. But what happens is your voice is taken, and that's it. That is its command. So it's not that particular Alexa or Siri or something that performs all these tasks. It goes to a central server where it's broken down and it comes back as commands. So those commands, see, if you think about it, a Siri or an Alexa is giving you information. It's playing a song. It's giving you information about the weather. So it's just doing that one task. when we spoke about Sophia, we said that Sophia is a conversational expert. We said that Sophia can engage in meaningful conversations with humans, but those conversations can be about different topics. But still, Sophia is only performing that one task. Similarly, the queries you ask may be of different topics, but in the end goal or the output is just one task, which is it's perhaps helping you with that query. If you ask it to tell you a joke, it'll tell you a joke. If you ask it to tell you the weather, it'll tell you the weather, and things like that. Is that did that make some sense? Wait, so Sunil has asked another question. As a follow-up to Meredith's question, what are some applications of, I think you mean reinforcement learning here? So some applications of reinforcement learning are, so as of what I know so far, even I'm not very well expert in reinforcement learning, but what I know so far is that reinforcement learning is mostly used in game development. So in game development, we leave an AI agent in a particular environment, and that AI agent performs a series of tasks. So like I explained with the tic-tac-toe example, that AI agent is left in that environment, 3x3 grid, and it performs a plethora of tasks over there. And then based on that, it gets positive or negative feedback. So this can be related with many other games. And in that game environment, it performs a lot of tasks. And based on whether it performs the task correctly or incorrectly, positive and negative feedback is given to it based on points. Okay, great. So Virginia, I'm sorry, I'm not very good at pronouncing your last name. So she asks the difference between data science, data engineer, and data analyst. So, okay, data science deals with all of this. That is, data scientist has to know how to deal with data. Data scientists have to know what data engineer knows. They have to know what the data analyst knows. They have to know everything. So data science follows all the fields, as in they start. Okay, I didn't want to explain this in length, so I'll just tell you in brief. Data science process has collecting the data, analyzing the data, scrubbing the data, which is cleaning the data, and then perhaps visualizing it, and then forming models on it and deploying it. So a data scientist must know all of this, So they must have good statistical knowledge, they must have good mathematical knowledge, and they will, so if you're a data scientist at a particular company, you will be working on that domain. So let's say you're a data scientist in a financial company, so your domain will be finance over there. Data engineer here refers to mostly dealing with data. So so you might have a lot of data to deal with. So there are many different tools like Spark, Hadoop that help you deal with data. So when you have large amounts of data, how to process it, how to get meaningful relationships from it, how to basically process it efficiently. That's what a data engineer does. Data analysis is the next step. So once the data is processed, what analysis can you do? What patterns are there in the data? Like we spoke about in the breast cancer example, once you collect the data, so collecting the data engineer does. Collecting and keeping the data is what data engineer does. Now analyzing this data, finding the meaningful relationships, finding what causes the person to get breast cancer and visualizing it perhaps, that is what a data analyst does. So for one to be a data scientist, must one be a data engineer? Yes, you must know the qualifications that a data engineer has. Okay, so I think Eunice, and I think that's it. That's all the questions that were there. So I will be moving on to the interesting applications. Do keep asking your questions. I'll finish these interesting applications and I'll try to reply to them as much as I can. Okay. So let's move on to interesting applications of AI. So the first application we'll be talking about are self-driving cars. So what are these self-driving cars? These are cars that can automate and navigate on their own without much of human intervention. So these are also known as autonomous vehicles or robocars because they have the ability to perceive the environment that's around them and move safely with not a lot of human intervention. A fun fact here is the first set of fully autonomous cars actually appeared in the 1980s. So now you might think, how exactly does a car perceive the environment around it? So it has something known as sensors. So these sensors can help in understanding what is present right around the car. And this sensor actually helps the car to map an environment. So let's say you're taking this car around a neighborhood. So the sensor will actually sense and detect what obstacles are present in its path, how the terrain of the road is it steep, is it steep or not steep, is it bumpy, things like that. So that's what the sensor does, and it draws a map of the region around. Now that particular sensory input, that particular environment that it has perceived is given to the machine learning algorithm based on which the self-driving car runs on. So this machine learning model, what it does is that is what helps it to chart an obstacle-free path for the car. So it will understand, okay, so it will know that, okay, so now I'm right ahead, I'm going to perhaps hit a bumpy road. So in that bumpy road means that I should not go too fast, I should go slow. So it will slow down the speed of the car. It will understand, okay, right here in front of me, there's perhaps a dog passing, so I must stop now. So it will stop. Or it can understand that the signal, that is red signal, green signal, or yellow, and it will understand when it has to stop and go. So Tesla and Google are the top two companies. They've done the most work in this field. And what we see here is a Waymo vehicle. So Waymo is Google's self-driving car project, and this is the testing of a Waymo vehicle. So this is just for your information. There are different levels of autonomous automation in driverless cars. So we have from level 0 to level 5. And Tesla's self-driving car, which is also known as Tesla Autopilot, has reached level 2. So it performs certain tasks on its own, but for a lot of other tasks, the human needs to be pretty alert. And Google actually has reached, with Waymo, has reached level 4. So this can perform most tasks on its own, but it will need human intervention at certain places. Now, level 5 has not been achieved at all right now. There are many reasons for this, because we don't know what else we'll be expecting. We don't know all the different scenarios that car can handle. So for that particular reason, level 5 has not been reached, and we still do need some human intervention, but the maximum reached is level 4, that is by Waymo in Google. So the next application we'll be talking about are AI-powered personal assistants. So the moment I mention the name personal assistants, and as we've been discussing in this whole call, you might think of Alexa, Google Home, or Siri. So these are also known as intelligent virtual assistant or intelligent personal assistants. So as Sunil asked a question, he asked if they're narrow intelligence or not. Yes, they are. Because what they do is they take the user-based voice, they take that as a voice query, and then they perform the task according to what you're saying. So a fun fact is that the first ever intelligent voice assistant was called Simon and was developed by IBM. So for a voice assistant like Alexa, Siri, or Google Home to actually perform its task, it uses something known as natural language processing and speech recognition. So this natural language processing is actually another branch of AI. We'll not be talking about this in this session, but you can feel free to look it up, because it's very interesting and very vast field. So now let's just brush over how Amazon's Alexa actually works. So for Alexa to actually wake up and detect a query, there must be a wake word. So all of the assistants we know have wake word. Google Home has OK Google, Siri has Siri, and Alexa's wake word is Alexa. So there is a technology in Alexa that helps you to spot the wake word, because Alexa should know that whatever comes after the wake word is the query that you're asking. So this wake word spotting is done by technology called keyword spotting. So that's what it does. So then it knows Alexa, that means it wakes up, and then it knows that whatever else you say right after Alexa is a query. So then that query, what happens? So that request, it is sent to Alexa's voice services. So that's what, there is a central head like called Alexa's voice services. And of there it's passed into a form that Alexa understands. And once it's passed into a form that Alexa understands, the output is again, because once you ask Alexa a question, it will reply back to you through audio. So the output from Alexa's voice services to Alexa would be an audio file. So this audio file is sent to Alexa, and then Alexa performs the task. So again, like I said, you can ask Alexa the weather or some other GK question, ask it to tell you a joke. So all of this is taken to Alexa's voice services. It is processed there and then comes back. So you should know that machine learning is the foundation of Alexa. So when I'm talking about machine learning, I also include deep learning, because that is a subset of machine learning. So machine learning is the foundation of Alexa. And I'm sure you all would have encountered some examples where the Google, the assistants, they go wrong. There are many funny videos also on this topic. But what it does is that it actually learns. So from wherever it goes wrong, it learns. It learns from these examples that are, these particular data from where it goes wrong. So it's constantly learning in that manner. So that's a wrap for today. And that's all I had to say. I hope you all had some learning from this session, and I hope that, in some way it impacted you positively. And I hope it also made you a little more curious about AI and its different facets. So now I'll open the forum for more questions, and you can ask me the same. Would quantum computers be super intelligent AI? So Toma asks, would quantum computers bring the super intelligent AI, or is it a long way away? So I don't think that is, I'm very sorry, but I do not know a lot about quantum computers, but these are also not super intelligent. Super intelligent is something that means that in a given field. So if you say I'm creating a super intelligent biologist, meaning that that super intelligent biologist would be the smartest in its entire field. Like no other biologist would be smarter than that particular device that you're creating. So it is, I would say, a long way, because we still don't even have general intelligence. We don't have general intelligence in the sense that we don't have even a robot that can act based on environment, is self-aware or driven by emotions. So to have a super intelligent being that's actually the smartest among all humans, that is still a long way away, is what I'd like to say. Toma, was that clear? You can just let me know in the chat box. Okay, Nada asks, what applications of deep learning did you use in your studies? So I've also not ventured a lot into the practical applications of deep learning, but what deep learning I have used or I have seen is basically related to image classification. So with images, the thing is that it's very difficult for you to actually find the, find features or find efficient answers or outputs using machine learning model. So for that, you use deep learning model, because like I said, in case you have to detect a face, you have different layers that detect different facial features that are present in that particular image. So Nada, did I answer your question? There are many other different applications of deep learning, like I mentioned, AlphaGo, and there are tons used everywhere right now. So speech recognition also uses deep learning. Deep learning is basically a set of algorithms that is used to process large amounts of data. So there are many other applications of it. I'm sure if you can, explore on your own and get back to me, that would also be really amazing. Okay, great. So Nada is okay. Deepshika asks, since strong AI has not been practically implemented, can a cluster of weak AI systems be called strong AI systems? So Deepshika, here, a cluster of weak AI would still be performing just one single task. Strong AI deals with not just performing that one particular task. It should be one machine. First of all, if you have a cluster, you still have many machines. I'm hoping that's what you mean. So you will still have many machines. No, this should be one machine. Like consider just one robot that can perhaps clean your floor, cook for you, open the door for you. It performs so many different tasks for you. So that you cannot consider a cluster of weak AI as strong AI. And strong AI, for strong AI to actually work, apart from processing so many different tasks, it should also be driven by emotions. As in, if you say something good about it, it should feel happy. If you say something bad about it, it should feel sad. And while Sophie was doing that by mimicking expressions, it doesn't actually have any emotion. But this should actually have some emotion, and it should know in its environment on its own. It should be able to analyze its environment, be self-aware. It should basically be like a human, It should get embarrassed, it should feel happy, it should feel proud, things like that. Deepshika, did I answer your question? You can put it as a thumbs up or anything in the chat box if you think I've answered your question. Okay, great. So Christina asks, what are some follow-up resources, classes you recommend to continue learning? So Christina, if you're a complete beginner, I would recommend this course called Elements of AI. I can actually show it to you. Just a second. Yeah, 1 minute. I will just share my screen again. Is my screen visible?
Yeah, yeah.
Okay. So this is so if you're a complete beginner, or even if you know a little bit about AI, I would recommend this course completely to everybody. It is a wonderful platform. It's an AI course that has been devised by the University of Helsinki. So it has two parts. So Introduction to AI has very basic theoretical stuff, and Building AI helps you with a little bit of programming. So I feel like this would give you a real good base if you're a complete beginner. Then you can go to Coursera, and you have a multitude of different courses there, such as Andrew Ng's courses, which I really recommend. They really help you understand the mathematics and all behind all this data science and machine learning models that are there. So you can explore lots of courses on Coursera, especially Andrew Ng. And if you would like, you can take up some books also. But yeah, Elements of AI is something that I would definitely recommend. Christina, I hope that helped. Great. So that's all. And that's all for today. That's a wrap. I guess I've answered all the queries. And this is my LinkedIn and Gmail if you'd like to connect with me. And if you have any other queries, suggestions, feedback about today's session, or anything else you'd like to ask, please connect with me on any of these platforms, and I'll definitely reply back. So thank you. That's all for today. I hope you all learned something today and had fun also along in the process.
Thank you so much, Sneha. That was an amazing talk. And I'm super excited, we can record it and get to show our community the event afterwards as well for the people that couldn't make it today.
Thank you,
For
Sophia,
anyone
for
here,
moderating.
no problem at all. I'm very excited to share this event with people afterwards as well. And we shared a lot of knowledge with us, and it was very interactive. The chat was going the whole time, so thank you for that. And also to Anais, who was our volunteer today, she was moderating the chat. You did a wonderful job as well, so thank you too. The recording will be available on YouTube probably around next week. There is a link in the chat there for that as well. I've also posted Sneha's email and her LinkedIn in the chat as well for anyone that wants to reach out to her, and add her on LinkedIn as well. So a big thank you to our attendees today. You were all wonderful and very interactive. So thank you for that. It's always good to, when we ask questions to our attendees in the chat and they answer. So, and then we also had a lot of people asking questions as well. So thank you for that to everyone. We're getting a few more people saying thank you. Thanks everyone. Thank you. But yeah, that's thanks everyone. I'm going to stop recording now. So there we go.